protocol from one device to the another device. Okay, so like we need to see
Yes.
CAN control area network. It is a multi-master protocol and it's message oriented, and it is a serial asynchronous communication protocol. Okay, so in CAN in OSI model, which layers we are using?
Data
Physical
link
and
layer.
Physical and data link layers. Okay, physical layer, it have the communications of wire communications will be there. Data linker, what it will have, it have a data where it will flow in the form of frames. So it contain data link provide, it have the address and the data frames into signals, and moreover where the actual information will be transferred in the form of signals. Okay, the data. Moreover, data link layer, it have the messages, the whatever the data frame we say, no. So the data frame or remote frame or errors, all will be monitored on the data link layer in the OSI model. Okay, what is the main principle of CAN protocol? So it will follow the wired down logic method. Okay, so it have a wired down logic. It have a the CAN high and CAN low. Okay, so what is 0 is a dominant and 1 is a recessive. This we know, right?
Yes.
Okay, so what are the uses of CAN? So it is a wire communication and more reliable and economic. It will be less cost and easy to implement. That is one important, and easy to integrate additional controllers. And if any failures are there, with the help of the CAN, we can easily identify. So like bus of errors or the faults related. So we are able to identify very easily. Okay. So these are the some main uses of the CAN and features of the CAN. So it's the same, like it is a simple and flexible configuration, and it will go with the priority. It will follow the arbitration process. So lawyer identifier will get the higher priority for transmitting of the data. And once the data is transmitted on the bus, right? So definitely it will reach that message to the other node when it is available. So that is a guarantee of latency time. Any delay, the message will be transferred. And configuration flexible, so we can remove and add the controllers in the CAN bus network. And it is a message oriented protocol, and it offers the multi-mastering communication, and error detection and fault detection are very easy in the CAN protocol. So whenever the message is corrupted, right? So the message is not reached to the receiver. So it got some like due to the errors or the fault in the bus network, it it not reach to the receiver end. So what will happen here is, so it will keep on retransmitting of the same messages until getting the bus of failure or active error or the passive error. Like we have the count, right? Until that it will keep on transmitting. So once that count completes, yes, again there will be chances in that software. The message will be keep on retransmitting will be happening. Okay, when the bus is ideal condition. And so if any node is not working, what is a node? Node is a device, right? The controller, or that is the microcontroller. So if the node is not detected properly, what will happen? It will automatically switch off. So when it will switch off after getting the bus of error. These are the features of the CAN. And what are the applications we discussed of the CAN? We are using in the passenger vehicles, trucks, buses, that is automotive vehicles. We are using this, and moreover, we are using the aviation and navigation, and industrial automation and mechanical control. We are using like industrial projects and elevators, escalators, and building automation, medical instruments. So all those areas we are using this application. And importance of CAN protocol is, so it is a multi-mastering and data consistency will be there. So, and the message routing and system flexibility. So these are the some 4 points that should be important in the CAN. Why CAN protocol is called a message oriented protocol? Based upon the identifier, we are sending the data. So in the form of frames, that is very important. So in the form of frames, we are sending the data. So that's why we call as that's why we called the message oriented protocol. What is a standard and extended? Standard is 11-bit, extended is 29-bit identifier. Okay, so what is the main difference? So in the frames, we have IDE. So IDE bit 1 means it will be the extended frame and 0 means standard frame. So why we are connecting 120 ohms resistors in between the CAN high and CAN low? Because to reduce the noise and avoid the reflections. Is it clear? And next, what are the why we need to know about sleep and wake up mode in the CAN? Because this is one more concept you need to understand. Okay, so generally, even our controllers also in the real time, it will go, it will be power on. Okay, so it will be power on. Like, so this is my controller, and I given power supply. Just assume I have the sensor, like radar sensor. Okay, so what happens is there is no object detection is happening. No object here means for radar no work now. So if the radar is no work means whatever the software application software in the controller also don't have work. Okay, and due to that what it will happen? It will go into the sleep when the application is not performing. In case if any object is triggered, immediately it will be awakened. It will wake up and it will detect the object. So that is a one point. And another point, so whenever the temperature means, suppose the temperature should be always uh, like 95 degrees is the higher degree temperature. If it crosses more than 95 degrees centigrades, okay, whatever the controller of the radar sensor, it will go into the sleep state, means it won't work. Okay, it will say that I need rest. Okay, so power off, like that, that is the indication the controller will give the info. So here what is happening is, so when we are doing power off, so the controller it will take rest for 5 minutes or 20 minutes. So like we need to do manual attention. Sometimes it will make the automatically it will be sleep, it will awaken when the temperature reaches more. Okay, so what's happening is in real time when we need to do the testing, we are we are checking the sleep wake up concept, sleep and wake up. We are making the controller to sleep and wake up. Okay, so here the sleep wake up mode in the CAN is to reduce the system power consumption. A CAN device sent to the sleep by disconnecting the bus drivers. So just if we remove the bus connectivity, the EC will go into the sleep state. And wake up is done by any bus activity or internal connection of the system. So we have one signal, okay? So we usually say NM message means network management. Network management. What we are doing this, so we have this CAN NM. Okay, so where we usually perform sleep wake up with this network means whenever you will give the sleep NM, so that time the sleep the network will be disconnected. Okay, and when you will give NM wake up, okay, so that is a signal. So this is a CAN signal, guys. Okay, so whenever you do this, so it the EC will be wake up. Okay, that is the one part of testing we usually do. Okay, so here, when it is in sleeping state, right? Listen carefully. So when controller is in sleep state, okay, whatever the components inside the controller, it won't consume power. It won't consume more power. Means the current will be zero always. Voltage you are supplying it. Voltage is 12 volts you are supplying, but current is 0 amps. When you this is in sleep state. When it is in a wake up state, so what will be the current consumption? Current consumption is like 0.5 amps and voltage will be 12 volts. This is very important. Sometimes they will ask you on the real time concept on this. Okay, when how you know the first point that controller is whatever the software you are flashed is working or not. After flashing, you will see that current consumption is whatever the current is consumption is 0.5 amps. It won't be like it be the same, but it will be 0.5, 0.6, 0.8. It is above that. Okay, so it will be keep on varying because the current is a moving electron slide, so in the controller it will be keep on moving. So that time you will come to know that the controller is working. Okay, is it clear still now? So where you will see you have a power supply. You know about power supply? Power supply, you know? I'm there now.
Yes, yes, ma'am.
Yes, and
Okay, power supply is like this. Okay, so power supply, DC power supply. So like this it will be. Okay, voltage and amps. This is a DC power supply, whatever we are giving to the controller. Okay, so we can see the voltage and current. Current is voltage is 32. Sorry, voltage is 32 and current is 0. Is it clear? Sometimes they will ask you what type of power supply, which company you are using. So you can say Textronics power supply. This is a good power supply. You can say this Textronics. Okay, even they have the good completely they are selling the oscillators, function generators, power supplies, many things they are doing the supplying. Okay, is it clear?
Yes, ma'am.
yes, and
Okay, so what is the speed of the can? So it is a 1 Mbps. We have the high speed and low speed. So high speed, if any problem is there while it will work or not. High speed, it won't work whether it will be the high speed or low speed. If wiring issue is there, it won't work. Okay, so that is a one point. Why can is asynchronous? So it won't depend upon the clock for transmitting of the data. Okay, so that's the reason it is a asynchronous. And internally, so when you are communicating, right, can high and can low, the internal logics which are the transistors, NOT gate, and the diode gate. So these are the like when you are connecting to the CAN bus, so we use the CAN high and CAN low, right? So it have internally it have this logics. Okay, because of this logic implementation, these are electronics components, no? So because of this, we'll get to the ones and zeros activation on the canvas. It will follow the wired and logic. So that's what, whatever the circuit here it is there, right? It is a wire and logic method. Okay. Can high and can low. So these are the voltages. So when there will be data will be transmitted, can high it will be 3.7, low will be 1.25. So whenever it is in ideal condition, it will be 2.5 volts. Okay. So next is the dominant and recessive. We know what are the bus values. What does standard can frame format? So you all know that frame format, whatever the data frame you need to write down. What are the fields in the standard can frame? So we have the start of frame, arbitration frame, control field, data field, CRC field, acknowledgement, end of frame. So we have this. And types of frames: data frame, remote frame, overload frame, and error frame. These are the four are important. And we have the other frame. This is not a completely frame, but whenever the message we are transmitting, right? So the each and every message you have some gap. So that is the interframing spacing we usually say. So standard frame, we know all these fields, and this is in detail. And error frame, we discussed error frame, it have the 0 to 12 superposition flags, and 8 is a recessive. So you need to remember always this 8 recessive bits. So so here we have the 12 bits. This will be the 12 bits, and this will be the 8 bits. So totally this error have how many bits? 20 bits, huh? So in these 20 bits, 6 bits are flag, means whenever you will get the error, these 6 bits will be 0, and echo, it will be the same bits, and this delimiter is always ones. You need to remember this. Okay, what is error flag? Can you explain me what are the error frame? What and all it will be the fields you have. And next is a overload frame. It is similarly like the error frame, but here you have the 6 bits flag, and next it have the delimiter. Delimiter is the same 8 bits. Okay, so this is the same 8 bits. Okay, here you have very less. Like here we have a 12, here we have a 6. Only that is the difference you should remember. Okay, so whenever the message is transmitting in the network, we have a data frame, so remote frames, and between you will get the error frames, and overload any delay will be the from the node. Then we'll get a overload frame. Okay, so what is arbitration? You know, and what is active and passive bus of error? What is a CAN bus of error? So how to achieve the methods of CAN bus of error? So how you are creating this bus of files? Can high interrupt, can low interrupt, short to bad, short to ground, short to shorting of high and low. So like this, you will do. You will completely remove the connection, loss of connection to the terminated network. So you will get the bus of Y 20 ohms. So like recovery of 120 ohms. Okay. So if 120 ohms is not working, so you need to identify from the hardware side between the high and low, that if resistor is not working means you won't get the message data and the CAN trace. Okay. So and there will be automatic recovery. So how you will do this automatic recovery of the bus of error? So sometimes they will ask you on these questions also. So physically you will verify on the network. So if there are no communication is happening, then we'll see the physical level first. So coming to the wires, we'll check 120 ohms, we'll check whether it is working or not. And once the hardware part is clear, then I will verify on the software level. So from the software, just I will wait for some time to recover automatically. So like that, you need to give the answers. So types of errors and bit stuffing error and CRC error. So what happens if we are sending more than 8 bytes of data? So we need to use CAN-TP, that is transport protocol. That is the method we should follow. What is a bit rate? And this is arbitration. like who will win first if I am sending 5555 and 500. What happens when two nodes are sending the same identifier at the same time? So what will happen? I have two identifiers, two IDs. So it will send or not? Identifier is two IDs have same.
Yeah, based on the
Hmm.
arbitration.
Okay. So two nodes are not allowed to send the message within the same ID. Within the same ID is there means it cannot be happen. So if it happens forcefully to send the message ID at the same time, so one of the significant property in the CAN protocol, that is arbitration won't work. You need to give this. So instead of transmitting the node with defect, his own message is discarded outside the arbitration field. Generally, the arbitration won't work. So in this case, what will happen? Any one of the identifier will be discarded. Means it will be um, stopped, and other will start communication. So it will follow the CSA CMA method. Okay. So that is the further. So this is the CSMA CA collision carrier sense, multiple access, and collision avoidance. So without colliding where of the identifiers of the same identifiers, so it will try to transmit the data. So if the bus is ideal, then it will start transmission. Otherwise, it will wait for the bus to be ideal. So until that, the messages cannot be transferred. Okay, this is a one method. And CSMA CD is carrier sense multiple action and collision detection, collision avoidance, CA, collision detection. So collision avoidance is when bus is idle, then it will start transmits. Otherwise, it will wait for the bus to be idle. Collision detection means it will detect the collision, okay, and stop the further transmission of the data and initiate the data retransmission. Because as I told you, right, we have the same identifiers. So when you have the same identifiers, so when you start transmitting the data, so what will happen? You will get a collision. Okay. So due to this collision, both the data will be lost. So at that time, the one node will be discarded. Okay. So other node will be in ideal state. So again, what it will do, it will do retransmit of the messages. Okay, that will be happening with the help of this method. This is a method. So it is used to avoid collision and data corruption. What is acceptance and filtering? So it is used to like acceptance means accepting of the messages. Okay, whatever the received CAN messages according to their ID. So from where is not interrupted by the message. So means whatever the firmware means, whatever the hardware and software related things, it won't be interrupted by any messages. Means so whenever it accepted only, then only the message will be transferred in the network. So that is what these are the data encryption. It won't be much important, these concepts.